Okay. Good morning, good afternoon, good evening, and good day, generally speaking, depending on your time zone. I am very, very happy that we are starting this this discussion panel chaired by Rob Hyndman, and and I don't want to steal more of the precious time, folks. If you have any questions regarding the prediction versus forecasting, please ask them in the chat, and I am leaving right now the floor to the chair of this panel, Rob Hyndman.
Thank you, Michal, and welcome everyone. Nice to be here. So let's start with some introductions, because I don't know everyone on the panel, and I'm assuming the audience doesn't know everyone on the panel either. So first of all, let's begin with Thiyanga Talagala from Sri Lanka. Just introduce yourself and say something about where you're from. Thank you.
Hello everyone, I'm Thiyanga Talagala. I did my PhD at Monash University of Australia, and I received my PhD in 2019. Currently I'm working as a senior lecturer in the Department of Statistics at University of Sri Lanka.
Thank you. Next one, Artur.
Hello everyone. I started applications of mathematics in industry and business in late 90s, and this is what I've been doing my whole professional life. And in the meantime, I got PhD in mathematics.
And Harleen?
Yeah, I'm a senior faculty and a chief investigator working on some of the projects. And recently I worked as a research fellow in UNU, United Nations University in Tokyo. So I worked on some of the project by Minister of Science and Technology in India, also in Malaysia also. So I have a lot of experience, 15 years of experience on a machine learning projects, and working on that machine learning and analysis and modeling of techniques.
Thank you, Harleen. And I'm Rob Hyndman. I'm a professor of statistics at Monash University in Australia. I've been doing forecasting pretty well all my career. I was editor-in-chief of the International Journal of Forecasting for about 14 years, and I'm currently head of the Department of Econometrics and Business Statistics at Monash University. So we have a diverse range of backgrounds and experiences, and we've got people in 4 different countries here: Poland, India, Sri Lanka, and Australia. So we're pretty much spread around the world, and I think we'll have a rich discussion as we bring different things to the table. So let's have a look at the questions that have been coming in. Let me start with the first one we've got. It says, can forecasting be automated? And what are the limitations of some of the automatic solutions, such as profit? So who would like to go first on that? So Thiyanga, you've been developing an automatic forecasting algorithm. So you obviously believe that forecasting can be automated, or you wouldn't have tried to develop an algorithm. So what are the limitations to the sort of work that you do there?
Yeah, I strongly believe that models badly need humans to stay awesome. Role of human in human machine system is very important. Where we can develop an automated algorithm for forecasting, but when we develop an automated algorithm for forecasting, always it develops on top of some human thinking. So usually when we develop an automated algorithm, developers develop that for a particular application. So when you apply that automated algorithm for a different times, different data set, different application, so there could be a mismatch. So we can automate the forecasting into some extent, but generalizability of that is questionable. For example, especially when you get new data, for example, when you are developing a automated algorithm for a business or for a company, the business strategies might change, and there could be change in data structures. So in that circumstance, we should teach the model this is the new dynamic to stay relevant. So I always believe we can automate the process in order to some extent in order to save our time and computational cost, but they need a human intervention in order to stay relevant and in order to keep the sustainability of the model.
Yeah, I think that's really important, actually, that along with the automated algorithm, you need some other monitoring system so you know when it's gone wrong, when something's not worked the way it should. And that's where you need to focus your attention. Most of the time, the algorithm should work fine, and you can't look at thousands of series. But if you also have some kind of monitoring so that you can pick up when you do need to give it attention, that's pretty important. Artur, do you use automated forecasting at Quantup?
Yes, we do use them, but it's not the only approach. What's important for me in our project is to have some benchmark, for example, a kind of naive or seasonal naive method, to know what's easily achievable. The second element is to run a couple of automatic algorithms, but still think about selection, not just to use brute force and 12 algorithms. No. Think about seasonality, think about length of the data, choose a couple of automatic algorithms, design a validation framework or approach, and let them run. But in the meantime, we are thinking about how to approach the problem, how to generate predictors, feature engineering. I still believe, maybe I have an old school approach, but I do believe in feature engineering and in thinking about the problem to solve. So when it comes to the project execution, it's very important for us to deliver something reasonably good in a very short time. If you have the timeline, you need to have a result here and time to think and improve here. So we have the benchmark, we have the first reasonably good method. We do experiments with automatic forecasting, but we are thinking all the time. And what I believe is visual inspection, just to look at the results, not just to measure them. And this is important for me too, just to look at the results in a longer term, shorter term. And exactly as you said, to have control over the models in production environment. If you have an automatic estimation, to prepare some rules about error when you build the model. No, this model is not acceptable. Don't use it in production. So basically, this is what we do.
I wouldn't call that old school. I'd call that good practice.
Probably nothing sophisticated, but just a good practice craftsmanship.
Yeah. So you're using a couple of simple benchmarks there, naive and seasonal naive and things like that?
Yes, exactly. Or linear regression sometimes.
Yeah, that's always a good benchmark, and it's a good it's sort of a good check that your fancy newfangled deep neural net thing is actually doing something useful. If it can't beat a linear regression, then there's no point doing it.
I think it's a common mistake if someone starts from sophisticated methods and doesn't compare it to very basic methods like a flat forecast.
Mm-hmm. How about you, Harleen? Do you have your favorite benchmark that you like to use when you're developing new tools?
Yeah, some of the ARIMA technique, auto-regression models we have used in that. But the thing is that human intervention is always should be minimum. Then only we can work with that. If we say the whole my predictive system or generalized predictive system will be automized, it won't be possible. So I believe that human intervention should be always there. A lot of other type of model that we want and that we want the growth and type of working we do. Some models are just like auto regression models are there. ARIMA models are there, or some seasonal ARIMA models are there. So these are models we can work with that if we want to do a automated system. But still, I believe that human intervention is always required for that. Then only we can able to work with that. So the thing is that the fully generalized predictive system, if it is automized, no human intervention is there, still I believe that the persons or people is required for that. I know that accuracy, the system will be more accurate. I know it will be more faster, but a lot more models are there where we can work with automated systems.
One of the issues I've found is humans often intervene in the wrong ways. So a lot of organizations I've worked with, they'll have an automatic or statistical modeling system that will give them forecasts of sales or demand or whatever they're interested in. And they go to a team of managers who are then able to override them if they think it's necessary. And they'll almost always override them in the wrong ways or the wrong series, and they'll make things worse. And you can test that. You can look at how accurate the original forecasts are compared to how accurate the adjusted forecasts are. And usually the adjusted forecasts are worse. So part of it, I think, is teaching not so much the data scientists, but the people who are using the forecast not to override them in the wrong ways, and to learn to trust the system. Let's talk a little bit about COVID, which obviously COVID has had an impact on a lot of time series and therefore has an impact on the work we do as forecasters. So what has been your experience, all three of you, in dealing with COVID effects on the sorts of things that you're trying to forecast? Maybe Thiyanga, do you want to take that first?
Yes, sure. So one of the main issues we faced when we try to model COVID-19 data is the availability of the data and as well as the accuracy of the data. Because the case count data often updated as new data made available. A case count data point published today may be updated next week or the following week as new data appear. So this is called sometimes the backfill due to the number and the variety of numbers that compromises the complex reporting of the hierarchy. So that's one of the main issues that we got. And also when it comes to COVID-19 data, always any model building process starts with the data wrangling. Different institutions report data in different formats. So gathering, cleaning data often requires more time than the actual time itself. That's another problem we got. And also we got the problem is the visualizing the data itself hard. For example, like in our country, we have 25 districts. Visualizing 25 districts, it's very hard because it's how to compare across the time series.
Are you producing official COVID forecasts for Sri Lanka, or are you doing this just sort of because you're interested?
I'm just doing it because of my interest, because I've got a student working under me in industrial training project. So she's working on the visualization process. I'm working on the modeling part of the process.
Does Sri Lanka have an official group that does COVID forecasting that goes to the government to help them with planning and policy responses?
Yes. But I think the committee mostly compromises doctors and health officials because they always believe the judgmental forecasting is better than the forecasts produced from the models. And it seems to be and the judgmental forecasting in the case of COVID-19 forecasting seems to be very accurate as well.
In other countries, there's been teams of data scientists that have been put together to do COVID-19 forecasting. So I'm on the Australian government forecasting panel, and every week since March 2020, we have provided probabilistic forecasts for each state and territory to the government, and that is how they make decisions. And I know there's a team in the US because we talk to them, and I know there's a team in Spain because we've interacted with them, and I'm sure most other countries have something similar too. Artur or Harleen, have you been involved in that sort of work at all?
Yeah, I've been working with the COVID data. Yeah, I have published a couple of results using a COVID data. But my main concern or major concern is the availability of a data, availability of accurate data. Because the thing is that COVID data, if we always work with a time series data. So time series forecasting, when we concern with that, we have to work on a machine learning models. So based on this data, we have to predict the future spread of the COVID disease. So availability of the correct data, the number of cases, number of deaths, recovery of cases worldwide within a specific time period. So this is a major concern on the availability of accurate data. So if we get a raw data, we have to clean that data. We have to do a feature engineering. So if we're getting from a public domain repository, accurate data is much more major concern, my concern. So because we have to work on a time series data, so such prediction we have to give. So predictive analytics doing on such data is a difficult task, but not that much difficult. So if we work on a raw data or if we take a data from a public domain repository, so we have to do a little much more task on the data itself to give the better or accurate prediction.
The other place that COVID has had an effect is often the series that we're trying to forecast, which have got nothing to do with COVID cases, but they've been impacted by the pandemic. And I'm sure Artur has seen that in some of the data that your company deals with. You must have seen a pandemic effect in the last couple of years.
There is a couple of cases. One of them is more related to prediction, but we don't know how to solve it. So I will not talk about this one. But what we did for demand forecast for fashion industry was just to take a very, very simple method, like something based on STL decomposition, to extrapolate the trend somehow and seasonal components. And it was the advantage was that this forecast used a short, let's say, after COVID data. So the basics were, the base was strong. And when I need to decide to go into something sophisticated or to make it as simple as possible, I'm recalling a project from past. We needed to forecast the effect of just a single event that never occurred in past. So what we did, we find something like a proxy measure for something should drive the effect of this event. I know this sounds cryptic, but it required some thinking and creativity. It took us a week. What we did next is we used recurrent neural networks to forecast, but from perspective of time, we will probably get maybe not that good results, but in a shorter time using a judgmental method. It doesn't need to be related to, doesn't need to be applicable for any forecast, but sometimes it could be good to assume that something will be reduced by 20%. I'm not trying to avoid sophisticated methods, but if we see that the influence of COVID is not predictable and we don't have data, I would consider either distribution forecasting based on a series of scenarios or assumptions, or something really simple, or based just on after COVID data, if it's applicable.
Yeah, so I've done similar things. One of the things that I talked about was forecasting tourism numbers in my talk just before this. And obviously, the forecasts for tourism have been enormously impacted by COVID. And so we've had to develop new tools for doing those forecasts. and we relied heavily on pre-pandemic data and modelling patterns, and then we used some judgmental adjustments to those forecasts to allow for the COVID effect. But it's it's a little bit ad hoc, but you have to do something that gives you results that people believe, and the forecasts that come directly out of a model, when it's using it's trying to model something that it's never seen before, is just not going to work. We've got a few sort of more technical questions, so let's have a look at those. So here's one. So how do you model time series data with linear regression? So I'm sure we've each done that possibly in different ways. So if you just had a linear regression benchmark, what are you actually regressing against? Anyone who wants to tackle that? Okay, I can do something. So a simple thing might be just a linear auto regression. So you just regress against the last 2 or 3 values in the series. So you've got, if your observation today is the output, then the observation from the last 3 days are your inputs, and you build a linear regression. That would be a simple tool. Or you might do something like a linear trend with some seasonal dummy variables, and you could fit that with a linear regression. So they'd be the sort of benchmarks that I have in mind if I'm going to use linear regression. Or if you're doing some bigger model, so you might be building a neural network and you have 20 or 30 inputs and an output that you're trying to predict, I would run as a benchmark the same inputs but as a linear regression, just to make sure that your neural net is doing something useful and is able to beat the linear regression. Does anyone else have any other things they might use that for?
Maybe decompose the time series into seasonal trend and remainder component, and try to model those components separately using the linear regression model, and then combine the values. It's one approach that we could use in that case.
Another question we've got here is, isn't forecasting outdated compared to deep neural networks? I think Artur would probably have a view on that.
I don't think so.
Sorry, my short answer is no, not.
No.
This is the first one.
Because deep learning methods offer a lot of working is going on a time series forecasting. So such as automated learning, or at some forecasting data, if we want to handle some automatic handling. So it will give a very good trends and results. So a lot of more recurrent neural networks are there, deep neural networks are there. So deep learning technique for time series forecasting is always a very good, it's not an outdated component. Because they allow to make a very good, reliable predictions on time series data. So the thing is that it is very good machine learning model.
Yeah, it's interesting to look at the history of the competitions and how neural networks have evolved. So in forecasting, the big competitions have all been run by Spiros Makrodakis, beginning in 1982, I think, with the M competition. And then since then, there's been the big M3 competition in 1998, the M4 competition a few years ago, and the M5 competition last year. And the first one where a neural network was put in as a competitor was the 1998 competition, and it did extremely badly. They fitted a recurrent neural net to each series individually, and there's just not enough data in monthly, quarterly, and annual time series, which are the series that were in that competition, to fit a neural network effectively, and they did terribly. In the M4 competition, there was some longer series, but mostly they were relatively short series of 100 to a few thousand at the most. And again, neural networks were put in the competition, and they did very badly and were easily beaten by a lot of the statistical methods. And it wasn't until the M5 competition that neural networks started to work well. And the reason was the M5 competition was a whole lot of data, about 50,000 series, but they were all from the one company, Walmart, all sales data of different products, and they could build one neural net across the entire data set. So instead of trying to fit single neural nets to each series, which didn't work and will never work with time series because the series are not long enough, we're building one neural network across lots of series, and that does work. But you do need to have sort of tens of thousands or more series before you're going to beat some of the statistical models. So if you've got a problem which has a smaller number of series or of lots of different series, you're much better off fitting more rigid models, more statistical models than neural nets. But if you've got, 100,000 or 1 million series that it makes sense to fit one model to, then sure, that can work reasonably well. So I think that's been the problem with neural nets, is people sort of misusing them and thinking that they're the solution to everything, whereas they're not. They will only work in some circumstances. Another technical question we've got here is directed at me. So the question is, how does the HTS package fit into the tidyverts framework? So the HTS package does hierarchical time series reconciliation, and it uses TS objects, so it's built on top of the forecast package. In the tidyverts framework, we're using Sybil objects, and instead of having a separate package to do reconciliation, the reconciliation is built into the Fable package. So there is a function in there called reconcile, which does the same sorts of things as the HTS package does. The big advantage is that it's much, much easier to specify the aggregation constraints, the hierarchical structures and so on, than it was with the HTS package. The big disadvantage is that it's not as computationally efficient. And we're working on that, but we haven't yet resolved it. So it's quite a lot slower than the HTS package at the moment. But hopefully that answers the question for whoever was asking. Another technical question, this one's directed at Thiyanga. The question is, you use random forests for choosing the best models based on features. Have you tried other classification tools like elastic nets or XGBoost? Random forests may have a collinearity problem.
Yes, actually, we tried other different models as well. For example, XGBoost, SVM, and also there's a model called efficient Bayesian linear regression approach. So actually, in my talk, I illustrated the forms approach in which we use random forest as a model to identify the relationship between the features and the class labels. We also have another algorithm called FORMA, which Rob, George, and myself and Pablo presented at the M4 competition, which ranked second in the competition. That algorithm help us to identify the weights for forecast combination. So in my case, the random forest is suitable when it comes to when you want to identify the best forecasting model. But with XGBoost, we can easily customize the objective function according to our need, and in that case, forecasting weights, we got the weights for forecasting very easily. In addition to that, the efficient Bayesian multivariate regression approach we used to forecast the errors for the class labels as well. So we can use different types of supervised learning algorithms, since we have features and y vector of values for y. It could be either class labels or the actual forecasting error. Which one to use? It all depends on the goal of your study. If it's to identify the best forecasting method, then random forest would work, but the other one would not. If we use if you want to find the weights for the forecast combination, in that circumstance, XGBoost might work, but the other one might not. It always depends on the end goal of your work.
Thanks, Thiyanga. Another question we've got here is about causal prediction models. Please share your views on causal prediction models on time series data, when and why to use it. So I don't have any real experience on that topic. Do anyone else in the panel have experience with using these causal prediction models? I don't think we're going to be able to tackle that question because we don't have any real experience in the group around causality. I mean, I guess part of the reason is when you're doing prediction, the causality is sort of a different issue and you're not necessarily interested in what's causing what, you're just trying to get a good prediction. Whereas studying causality is more about studying, the historical data and what things are causally related and what things are just correlated, which is a useful thing to look at, but it's a rather a different problem from prediction and forecasting. So I think people that do forecasting don't tend to think too much about causality and vice versa. Okay, so let's look what else have we got here on the list of questions that I've got. So here's one about forecast validation. What do you use when you're doing your forecast validation, when you're checking whether your forecasts are good or not? Do you use mean squared errors or CRPS or something else? And do you use time series cross validation or do you use training test set splits? So I'm sure we've all got our preferred ways. Maybe Harleen, what do you do when you're trying to check whether your predictions are any good?
Yeah, I validate the result using a 5-fold cross validation. After going through a features, reduction in the features. So the values what we get, I always work with a 5-fold cross validation. But here in my work, nowadays I'm using a 10-fold cross validation. And I look on the precision and recall values. And then I look on the ROC curve. So based on that ROC curve, I used to give a prediction, which is a machining after doing a comparison between various machine learning algorithms or models. I do a compare between ROC curves. So which one is better? So that one will be the.
You tend to be predicting binary variables, are you?
Yes. Binary and multi also. So the thing is that, multi-class also. So the thing is based on that. So if we get a ROC curve, so better, whatever the better will be there. So because in my recent work, I got a gradient boostring will be the better model rather than a random forest and other decision trees models. So one is a precision and recall values, cross validation. So then a second one is a ROC curve. And these are all validation metrics are there. Based on that metrics, we can able to predict. Yeah.
How about you, Artur? What's your favorite approach to validation of your forecast models?
That depends. I'm sorry for this answer, but first we start from the error criterion. So for the recent project, we use MASE because we had intermittent time series and there was a problem with 0. So, but we always consider what should we use, what will be understandable for the client, what could be the required precision. So sometimes we use just MASE for model selection, but we present additional results to show something more interpretable for the client. So we start from this criterion and we try to optimize against something similar if it's possible. So if we can play with the goal function, we try to fit it to this goal. And when it comes to cross-validation or just a plain learning test split, we prefer to perform cross-validation for feature selection. And to make it simple, yes, we do cross-validation CV for feature selection, and we measure as it should be measured from the business point of view. We measure the forecast quality. And of course, we need to play with the forecast horizon. We need to play with number of faults and all this kind of stuff. But basically, it's CV and one of standard measures of error.
Thiyanga, do you have any different experiences or you do similar things?
Actually, the method that I use for validation, it depends on the time that I have. If I want to give a forecasting model just very quickly for the clients, I just split the data into training and test and calculate the forecast accuracy over the test set, mostly on maze. If I have enough time and if I have enough data, I would go with the cross validation approach. It's basically depends on the requirement of the client and the time that I have, and again with the data.
This one's another question which also relates to sort of what our practices are. Do you tend to do point forecasting or probabilistic forecasting or interval forecasting or some combination? So maybe I'll start off on that one. These days I tend to do much more probabilistic forecasting, mostly because the sort of problems that I'm tackling, they're interested in the tails of the distribution, not in the middle. So I work on energy forecasting with electricity organisations, and they are interested in, the extreme tails of demand because they want to make sure that they've got generating enough power to meet the demand. And the median is not, or the mean is not the thing they care about. It's the extreme tail. And I'm also doing this work with the Australian government on COVID forecasting, and they're interested in the whole distribution. They want to know the probability of the outbreak reaching certain number of cases per day, because then they're going to have to change the mask wearing or people having to stay home more or whatever. So they're interested in the probabilities, not interested in single numbers. So that's sort of what I tend to do these days, is I'm giving people whole distributions. But anyone else? Other people do that, or are they still working on point forecast or intervals or what?
I mostly use the point forecast. I mostly use the point forecast and the prediction intervals because with the point forecast, there's no way to telling how accurate our forecasts are. So producing prediction intervals is very important because it's helped us to understand the uncertainty associated with the forecast. But in future, I'm trying to incorporate probabilistic forecasts for my projects.
And what we do for clients depends on a client. We would like to deliver probabilistic forecast to forecast the whole distribution, but not all the clients are ready to use this full distribution or some quantiles in business decisions. So sometimes we are sad to deliver just point forecasts with some prediction intervals, but we try to use probabilistic forecasts, or at least try to convince the client and tell that a kind of risk assessment should be good for using the predictions and taking decisions based on them.
Harleen, do you consider intervals or probabilities or just point forecasts?
Well, same here. Recently, I work on the weather data. For working on a weather forecasting, the probabilistic forecasting is the best technique. Yeah, because we have a different methods, events are there and some probability will be there. So I worked on a probabilistic forecasting technique on a weather forecasting rather than going for a deterministic forecasting. So I believe that probabilistic technique or forecasting will be a better way of working on a time series forecasting.
So let's look what else we've got. We've got a few technical ones here. So let me do the one about COVID. So in COVID case forecasting, do you update the entire model every day using the entire series of case counts, or is there another best practice for iterative model updating? So let me just say a little bit about how we do COVID case forecasting in Australia, and I know it's similar in some other places. We actually use a forecasting ensemble. We have 3 different models that are built by 3 different teams. So the 2 of the models are epidemiological models. One's a sort of complicated version of an SEIR model, which is sort of a standard epidemiological model, but it's been tweaked for this purpose. And another one's an agent-based model. And so they are quite large Bayesian approaches that use a lot of computation and generate lots of sample paths. So they're updating the model pretty well every day with new cases, and it takes hours to run them. The third model is actually a global autoregressive model. So it's using data from all of the data sets on the Johns Hopkins database, which is a public database of COVID cases. And we build a single model, a single long memory autoregressive model from that database. And we don't update it very often. Every few months, we might update the model, but otherwise the coefficients are fixed. And we found that that works really well. And then from the 3 models, we generate probabilistic forecasts, and then we mix them to create an ensemble forecast, and that's what goes to the government. And we test it every week to see how we're doing using things like CRPS and coverage probabilities and mean squared errors. We have a range of things we look at every week to make sure that the model's not doing anything crazy. But that workflow's evolved over 18 months. It was right at the start, it wasn't quite as sophisticated as that. But I don't know what other, I know the US team they've got about 30 or 40 models in their ensemble, and every one of those models, some of them are updating regularly and some of them are not updating quite as frequently. So, I think it depends on what type of model it is and who's doing it and how good your computer is to how frequently you want to update them. Couple of other technical ones. Let's go to this one. Do you consider the robustness of the independent variables? The person asking this says, I am from biological science, and maybe it differs a bit from the work you do, but it's important in biological models. So, when you're thinking about what independent models to put in the model, do you think about, I'm not quite sure what the person means by the robustness of them, but do you think about the quality of the data or anything else about the model, about the variable, other than does it help with forecasting? I know you use a lot of features, Harleen. What do you use to decide what goes in your models?
For robustness, I always believe that you should first work on the feature selection technique. Yeah, if we have a good number of features, a quality number of features, then only we try for a better model. So robustness or quality of my data, understand about my data. So we have to first work on the data rather than going for on the robustness side. So and the thing is that keeping in mind the predictive system or using a predictive technique, my main concentrate about the variables. So what will be my variables will be or features will be. So I should work on the raw data. If I'm having a raw data, we should work on the feature engineering side first, rather than go, because the quality of features always give a quality of result. Robust, my result will be much more accurate. So my belief is this. So we need to prepare the data for a predictive analysis model, rather than going work directly on the data. First, we have to apply on the feature engineering side.
Anyone got anything to add to that?
We do it incrementally. So we start from designing very simple features like dummy variables for days of weeks or something like this. We start with the first models, and sometimes we do brainstorming to come up with more sophisticated predictors to choose from. And next, we prefer to use simpler models to choose the variables, but sometimes you go for XGBoost and just let the model use the features appropriately. So, but what's very important for us in the process of building and delivering model is to do it incrementally, not to design hundreds of sophisticated features related to, I don't know, area under something. No, we start from something plain and simple and let it grow gradually.
I have a question here. Could you share your thoughts on dynamic linear models, DLMs, in terms of forecasting and time series model? Are you able to assess the usefulness of this method, and have you ever applied it? So maybe I can go first on that one. So DLMs are sometimes they're a form of state space model, so they're often taught along with other state space models. You can think of ETS models as a sort of a special case of DLMs. ETS being the exponential smoothing state space models. they're a little bit different from regular DLMs in that the error term is the same in each of the equations, whereas in DLMs, they're independent error terms in each equation. But there is actually a correspondence between the two classes of models, and you can express, or at least for the additive ETS models, you can express them as state space models in the more regular way. So in that sense, I use them all the time because I use the ETS version of state space models. I have used DLMs in other non-ETS type DLMs before, and yeah, they work fine. They're quite a flexible modeling framework, so they're quite useful, and they're particularly good at things like missing values because you can build it using a Kalman filter, and then if you've got missing values in your data set, then it doesn't really muck anything up. I haven't ever written software to do them because I figure other people have already written good software, so there wasn't a gap to fill. But nothing wrong with the models. They work well many times. Anyone else got anything else to add to that? No? Okay. So we've got about 10 minutes left. And I've got a few questions here, sort of more career advice sort of questions. So let's go to those. So do you have any tips or guidelines for new researchers in forecasting and predictive analytics? So you've got a new person who's interested in the field. What advice do you have for them? Maybe start with Thiyanga.
Yeah, so that question took me back to 2016, the advice you gave me and when I started my PhD. So the one important thing is when you read research papers, try to replicate their results. By replicating their results, you will learn lots of things. You will identify you will learn their methods, as well as you will sometimes identify the limitations of their methods, as well as you will the replicating process forms new ideas to improve the model as well. So so my favorite thing is about the replicating, try to replicate the papers rather than just reading and writing, try to replicating. By replicating others' work, you will learn lots of things. And the other thing is always try to apply those models, not just replicate to the data sets given in the paper. Try to apply those things into a new data set and see why that model fails and why it performs best on series. Likewise, you need to deep dive into the modeling process and always try to identify the limitations. That will with that, you will get lots of knowledge, and you will be able to expand the knowledge. And you will, while doing that, you will identify the prominent researchers in the field and the places to look at. So that's the sort of process that I used when I was back at Monash when I started my PhD in time series forecasting.
Sounds like great advice, Thiyanga. Harleen, you were going to say something on this.
Yeah, I agree with Thiyanga that replication is very important, the work on the replication part. The thing is that for a new researcher to prepare with the data for a predictive modeling, you have to identify what type of sources you are taking. Whether you are working on a public domain repository, you should be aware of which data should be from where I can get the data sources, because you have to identify the data sources and how you will be going to access the data. If you're going to work on the qualitative data, is it okay? If you want to work on the quantitative data, you have to gather all the things. So you have to consider the variables, what variable you want to analyze. Either you work on the dependent variables or independent variables, you have to identify that thing. Then you have to have a good analysis on the data. So whether you are using a derived variables or you're using something different variables. So you have to explore on the quality of the data, because the quality of the data is very much important. You have to understand about the data. And then after understanding the data for our new researchers, then you have to work on what type of predictive machine learning model will be the best suited for your data. If you're working on a classification problem, if you're not working on a classification problem, then what type of machine learning models will be best suited? You have to understand the basics of the predictive machine learning models. So new researcher should always get a good knowledge about the machine learning models. Then working on the variables. Then how you will be going to implement it, how you will be going to interpret the results, what will be the validate, how you will be going to validate the models, whether you will be going to use a unifold, whether you will be going to k-fold, 5-fold, 10-fold. You have to understand how you will be going to interpretation of the results and how you will be going to validate the models. So validation will be of many types. So the better is that you have to understand about the data for the predictive analysis modeling. You have to understand on the machine learning model, which will be using for the classification problem, which will be using not for the classification problem. So the whole understanding on the data science, on the machine learning, on the statistics, on the mathematics is always important, because all these fields are interdisciplinary fields. So all these fields are very much important if new researcher will be going to work on the forecasting and predictive analytics areas. So these fields are very important.
I could add something, maybe not about research, but about applications. Rob, do you think it's good?
Yeah, please go ahead.
Okay, so I'll start with a story. When I was a fresh graduate, I started my first job in a bank, and I was told to forecast sales of loans, monthly sales of loans. So I was just after a course in time series at the university. I took Statistica. Maybe someone from you remembers Statistica software. It was the only software at late 90s accessible in the bank. I prepared the data and I put this data into the software. Of course, it was seasonal. So December was similar to December last year. And I was thrilled to see the first real results. I put the data into the software and the error message was you need at least 3 years, and I had something like 2 years and 1 month. And it's always like this. When I use standard methods, I need to tweak them to prepare something ad hoc. And what turned out to be very important, that are the basics to understand the fundamentals of exponential smoothing, ARIMA, linear regression. It's very, very important to understand what you do, what are limitations, and don't use the methods blindly. Start from something simple, understandable, with full control, and see what happens. And it was always like this. I needed a tweak. I had a short data, very variant in time with very different distributions and so on. So my advice is to know what you do and to use simpler tools and to think. I know it could be useless, not easy to apply, but from perspective of almost 25 years of forecasting and modeling, it turns out to be the most important factor.
Thank you. That's interesting. I would sort of add to that as a researcher working in a university and doing methodological research, it's really useful to do a few consulting projects where you actually work with organizations and companies and learn what their forecasting problems are. And for me, that's generated lots of research ideas that I've then gone away and worked on, knowing that the work that I was doing was at least relevant to some organizations. So the whole ETS framework came out of a consulting project. Forecast reconciliation, that idea came out of a consulting project. So I saw the problem in a consulting project. I helped the client sort out the particular issue, but it made me think about, well, how would, I came up with a quick solution for them because you've always got a tight deadline, but it helped me think, well, what would be a sort of a more statistical, more principled way of handling this problem? And then that led on to what I think are some of my better research papers. So doing that sort of practical interactions with industry is really useful for research. If you're doing methodological research, it's really useful for making sure your research is on topics that are helpful and useful to people, not just tweaking someone's thing that you've seen in a journal article. Okay, we've got a couple of minutes left. Here's a question. Is there any research or analysis you conducted in the past that you would redo completely differently nowadays? Well, for me, I would redo every paper I've ever written differently if I was doing it now, not maybe completely differently, but I've learnt things over time and I would go back and I'd do it differently back then. So, yeah, I think I would redo everything I've ever done differently, but not completely differently. I don't know what other people think. You're all too young to have think back over too many decades to think of things you did years and years ago. Maybe we can just finish with a couple of questions about more advice. Can you recommend any international remote internship programs for young researchers starting their career? I don't know, are any of you familiar with international remote internship programs?
Yeah, there are a lot of Microsoft internship programs are there on data science, on predictive modeling. These internship programs are there. IBM is also giving some data science engineering internship programs. And other are there some United Nations also. International Monitoring Fund is also providing some internship programs where the internship student will be get paid, and then they will be going to give a salary and some round trip, economy class, a lot of other benefits they will be giving to the internship if it will be offline. So a lot of online programs are also there. So Microsoft is there, IBM is there, a lot more are there for the young researchers. They can do this program offline also, online also. And if they will be offline, they will be get a very competitive salary. They will be get paid. So okay. A lot of in forecasting and predictive analytics, a lot of internship programs are there.
Thanks, Harleen. That's very useful. And I see Mikhail's back, so we need to finish up.
Unfortunately, we need to wrap up this session. I want to thank you all for participating in this panel. I think we are living in so the science is always in the state of the breakthrough, but I think the forecasting is really really altering its image, and we are encountering and as we see in, for example, in the Thiyanga's paper, we see a new approaches to do better and easier to easier do more forecasts. So at least for me, from the technical and methodological point of view, we are living in a very important time, and I think this is as a matter of forecasting, this was a very timely panel. So so for all of you, thank you for being here, and let's switch to the next session by Pearson. Thank you, and have a lovely day.
Bye-bye.
Bye.
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 Bye. Thank you.
Thank you.
Okay, folks, and